Hello everyone, I see that only the toughest have survived so far. Okay, so I'm a lead data scientist in Kraków Software Lab. This is IBM, the only IBM software lab in Poland. And I have a pleasure to work on Watson Machine Learning service offering on cloud. So today I'd like to talk a little bit about the way that model needs to go through to become a production model and how that production model can be consumed by external application. So I got only around 7 slides, so I will go really quickly through them. And I think that I'm gonna focus on the live demo of the whole end-to-end scenario. So during those demos, I'd like to answer those 4 questions. So what happens after a model is created? What is Watson Machine Learning service on IBM Cloud? How to move from model to production application in minutes. I hope you're not gonna cash it time me, what we'll see. And the final question is how to ensure correct model quality on production. So let's start. So yeah, it's a really nice statement actually. I love data scientists. So I got in my team actually I got data scientists and I got application developers, and let's put it that way. Those are completely 2 different worlds, and very often it's really hard to get them to communicate together in the way that we kind of get an efficient team. So I've got an example here, example of the chat between the application developer and data scientist. So Mark actually is application developer. So what Mark says, if the end goal of data scientist position is a software product, that then at minimum they need to be able to communicate with developers. And we see the next chat from the John, who is a data scientist. I have this shiny app, could you add billing, logging, and so on to make it run on production? And what happened next? Mark, hell, is being handled 2000 Python script with no comments that queries database on laptop and being told, make this work in prod. So actually that happens very often. So the data scientist's goal basically is to provide high quality, high accuracy predictive models. So let's say that we got such model. The goal of application developer is to provide application that consumes the results, predictions of that model. And the question is what's between, what's the gap and what should be provided to fill that gap. So we can imagine that the following functionalities, the following features are missing. This is the collaboration platform that we allow to collaborate, to communicate data scientists with the developer. There's a deployment capability, so the capability that will serve the model in the form, for example, of the REST API endpoint that can be consumed by the web application, for example. Integration of that web application with the served model. We also need the capabilities of monitoring of the model in the production to make sure that the model running in production, providing some kind of predictions, provides accurate predictions. We need the capability to retrain the model, to have the model up to date, and of course redeployment of the model with the newest retrained version. So what's the Watson Machine Learning service? So the Watson Machine Learning service on Bluemix, Bluemix is the name of the IBM Cloud, provides such functionalities. It provides 2 different interfaces for the data scientist and for the developer. So the data scientist, we got data science experience, which sounds quite similar to the data science work presented before my presentation. So we can kind of jump into it for a second, but what's more important, it provides the interface for the application developer, which basically is DevOps tooling, DevOps services, which are a bunch of different services like databases, like tool chains, like IDE on web, like Git integration and so on, and everything actually in form of the cloud offering, cloud services. So I'm not gonna go into details here because I'd like to move to the demo. So briefly, Watson Machine Learning provides the ability to build models. The models can be built either through using a data scientist programming skills, for example, Jupyter notebooks, but also provides the cognitive assistant for the data scientist. So you basically provide drag and drop the data you got, and it tries to figure out the problem you are trying to solve. And from the huge set of different algorithms, learners, it provides the one that, according to the Watson, are the most optimal, the most accurate ones. So this is like a, let's call it like a black box. You put the data into it, and as an output you got trained models. You can also use a canvas, or in other words flow. So you basically build a stream using drag and drop features, node by node, like a graph. It supports open source, so if your favorite tool is SparkMLib or scikit-learn or XGBoost, you are free to use it. And what's the most important thing, it provides serving capabilities, deployment capabilities, which allows you to serve a model as a REST API endpoint that can be easily integrated with the application. Bluemix itself, this is like a cloud offering for developers. It provides a huge batch of different services and also provides unique capability to bind those services with your application. It also provides the DevOps tooling, it also provides runtimes monitoring, it also provides the runtimes configuration, HA, and so on. I'm kind of spinning up. Yep, workflow. So you have probably seen today a lot of diagrams which basically shows the same. So the basic flow of the machine learning process is, we got historical data, we pre-process the data, we train the data, we validate train model, we use the test data to validate train model, we deploy, serve the model, we make predictions, based on the predictions we make some actions. Then we got a feedback data store and metrics. So the feedback data store is the data store which contains records for which we know the target labels. However, those records were not used in the training process, so they can be used in the monitoring process to figure out how good our deployed model is. We'd like to detect situation when the deployed model provides incorrect predictions. And actions. Yeah, why actions are important here? So maybe a story first. So there was a telco company which wanted to have a really good predictive modeling to predict customer satisfaction. So they came up with such model. They sent the results of this model to the marketing department. The marketing department took the list of the customers that were predicted as customers that are not satisfied with current offering. They called them. So they called the first customer from the list, the one which had the highest probability of leaving the telco company. And what was the answer of the company? It's great that you are calling because I want to resign from your service. Thank you. And this is basically all. So they had no actions plan what to do with correct predictions. So this is also quite important thing. So going back to the feedback, based on the feedback data, we can easily detect that our model on production is not performing well. Based on the feedback data, we can also set up some kind of trigger actions. So for example, actions like model retraining and redeployment. I'm going to say a few more words about it in a second. So those three actions we basically call continuous learning system. So this is the system which kind of ensures that your model in production is being retrained and redeployed over and over to ensure the highest possible quality of the predictions. So actually this is all those are all my slides, and right now I think we can switch to some kind of demos. So I got two demos prepared. The first demo is the demo which shows how to move from the model development to up and running Node.js application on cloud. So for that demo, I'm using a product line prediction example. So the use case is actually as follows. So one of the chain stores in Europe would like to know what's their client's interest in product lines. Product lines like, for example, personal accessories, mountaineering equipment, golf accessories, and so on. So this is the first use case and the first demo. And next, I'm gonna show a second demo. In that case, we're gonna look at the model which predicts the best drug for the heart disease. In that case, we will focus on this continuous learning system. So let's start it. So let me just close the presentation. Okay. I hope you can see my screen. Okay, great. So what we are looking at right now is a IBM cloud offering, which is called Bluemix. This is, as a matter of fact, this is Bluemix Catalog. So the Bluemix Catalog contains a set of different services, different offerings, categorized under different topics. So we, for example, have an infrastructure. So in infrastructure, we can, for example, have bare metal server. So you can request a bare metal. You can request virtual server. Then you can have, for example, some kind of boilerplates. Boilerplates are templates of different services and applications combined together. You can have, for example, Cloud Foundry apps. Those are starters, for example, for Node.js application. So when you choose such starter, you will get a sample hello world Node.js application. You will get a blockchain, which basically is deployment pipeline, which integrates the code of the sample application with Git and with build pipeline, allowing you to redeploy your application code each time it has changed on the Git. Of course, we got, for example, Watson Group as well. Under Watson Group, we got plenty of services, for example, personality insight, language translator, conversation, speech to text, text to speech, visual recognition, and so on. So this is basically Bluemix. It provides a set of different services. Services can be binded with your application. Under this catalog, we got also the Watson Machine Learning. Okay, so if you'd like to use any of the services, you basically select it from the catalog. You provide a service name instance, whatever you choose. You select a plan. Most of the services, actually all of them, contain entry-free plan, so you can use this you could use it for free. And you basically create. I've got such service already created, so we can switch to the dashboard. So the dashboard basically shows all your services and hosted applications. So I have already created an instance of Watson Machine Learning for the purpose of this conference. Okay, each service instance contains such sections. So the manage sections basically provides a simple landing page with the dashboard UI that can be used to do some simple actions. What's more important, it contains service credentials. So the service credentials are credentials that are used to connect with that service to use it. So it contains basically the endpoint URL, username, passwords, instance ID, and so on. Information about plan and connections. The connections tab provides the information about the application that uses this particular service. So nothing sophisticated so far. Okay, so we got our service instance created. And as I mentioned, we can also, so we got our service instance created, so we can start developing the predictive models. So to start developing the predictive model, we can open the dashboard, which is called Data Science Experience. It looks like that. Nothing sophisticated, actually. It contains a project Notion. It also contains the community where people are publishing articles, dataset, notebooks, tutorials, and so on. So I have created a project for this conference, which is named Conference Demo. I think I got already open somewhere. Okay. So under the project, you can see several tabs: analytics assets, data assets, bookmarks, collaborators, settings, and so on. So basically collaborators, you can add users to your project, so you basically share all assets with those users. Analytic assets, so as I mentioned, you can use Jupyter notebooks to develop your models. You can use a models wizard, or you can use streaming pipelines or flows. So I got examples of the model wizard. So this is, I would say, like similar to the kind of like a black box. You provide your data, you set the target label, you choose a problem you'd like to solve, and the Watson runs series of the algorithms and provides you the best ones. So nothing special here actually. Let me close it. There are flows. You got a palette where you are able to choose set of operators and modeling algorithms. You basically drag and drop them, connect into a pipeline, and then run such flow to get your model trained. Let me skip it as well. So as a data scientist, I like Python. I'm a Jupyter notebook fan, so let's go through this simple Jupyter notebook to create a model and persist it into Watson Machine Learning service instance on Bluemix. So I'm gonna skip this setup steps. I already got the data downloaded. The data came from the community I was showing before. We got the Spark session created. We read the data into Spark data frame. Nothing interesting here. So we can print the schema of the data frame. We can see that the data is quite simple. It contains a product line. So actually the product line is the column, the target we would like to predict for the future customers. We got information about the customer, which is gender, age, marital status, and profession. Very simple data set. We can see the teaser of the data basically by calling dataframe.show method. Yeah, it takes some time. Okay, so we can see some kind of snippet. So we can see the product lines, for example, like personal accessories, mountaineering equipment, golf equipment, camping equipment, and so on. Gender, male, female, age 27, 39, marital status, single, married, and profession, for example, professional, hospitality, retired, and so on. Okay, number of records over 60,000. Next, we could prepare the data. So what I'm doing here, actually, I'm splitting the data into 3 subsets. The one data set for training, one for evaluation of this trained model, and the third one, holdout data, which is used to evaluate the model after optimization or tuning. Let me run it. Okay. Next, we create a pipeline. So we got a bunch of the imports. So the pipeline is a notion in machine learning. It's actually a definition which is used to train a model. The pipeline consists of stages. Most of the stages are transformers, and one of the stages is actually estimator, which is in fact classification or regression algorithm. So here we basically got a string indexer which transformed non-numerical data into numerical data. Nothing special here. Next, we got a vector assembler. Let me run it actually. Okay. Next, we got a vector assembler which combines into one vector features. Okay. Next, we got the estimator. In that example, I'm using random forest classifier. I provide the information about the label column, and I provide the name of feature vector. Okay. We got a label converter because we'd like to see label data of prediction instead of indexed one, so we just add it at the end. Okay, and we are building a pipeline. So as I mentioned before, pipeline consists of several stages. In that case, we got a lot of string indexers, vector assembler, then we got a classifier and label converter. So let me run it. So we got our pipeline defined, and we can start training our random forest classifier. Of course, the schema is the same. We call a fit method on the pipeline and pass the training dataset. Okay. Okay, model has been trained. We can evaluate the model using the multi-class classification evaluator and metric name accuracy. Yep, not perfect, but good enough for this example. Of course, right now we should start working on model tuning, model optimization, but I have removed this section basically to simplify the example. Next, we import the Watson Machine Learning client library, which is basically a wrapper on REST API. So I have already installed it, so we can skip this step. Okay. We got the credential. Credentials actually are the credential I mentioned before, which came from this piece. Okay, let me go back here. Okay. Okay, we are connecting to this particular instance of the Watson Machine Learning, and we are publishing our model into Watson Machine Learning repository on the cloud. So maybe just one remark here. So just for your knowledge, I have used native Spark MLlib training capabilities. I have not used Watson training capabilities because I like to focus on the second part, which is model serving, not training. Let me do one more thing actually, just to, okay, let's change. So this is basically the name under which this model will be present in the Watson Machine Learning service repository. So let me just call it like, for example, dummy model for data. Okay, let me save it again. Okay, we can get details of the model. As you can see, the client not only perceives a model but also fills some kind of metadata. So for example, we got the runtime environment, Spark to 0, and so on. We got the schema information, we got the pipeline persisted as well, and so on. We can of course load the model from the repo if we'd like to. We can check if the loaded model is the one we saved by checking the name of it. Looks like the right one. And what's more important, we can deploy this model either as an online deployment, batch deployment, on stream deployment in a cloud. And as a result of such deployment, we'll get a scoring endpoint. So let me just do it. Okay. Okay, so we got a scoring endpoint. This endpoint can be used to send new records of customers, and in a response we will get the predicted product line plus probability. We can of course get the details of that deployment. We can skip it actually, and then we can score. Scoring is basically sending records with unknown target label, and in a response getting the predictions plus probability. So we can score using a Python client, but I think what's more important is scoring using a bare REST API, because this is the way how the external application will consume our served model. So I've got a batch of the imports here basically to authenticate to the service. Then I'm creating a header, which is basically content type application JSON, authorization bearer plus token, which was generated based on the username and password. Nothing sophisticated here actually. Maybe one more thing I kind of missed, just scoring payload. So we provide a new customer record in the form fields, which is basically the header. So we got gender, age, marital status, and profession. We don't provide the product line because this is the target we'd like to predict, and some values. So we send a customer who is student, single, 23 years old, male, and the second record, which is male, 55 years old, single, executive. So let me just... Okay, and let's run the post request with such payload, and in a response we expect to get the prediction information. So we can see that predictions are camping equipment and mountaineering equipment for the second record. There are of course probabilities for each of possible labels and also information about the values of each stage. So we got our model at this stage, we got our model deployed on the cloud, we got endpoint, scoring endpoint on the cloud that we can use to send new records and get the predictions back. So what we are missing at this point is application that will consume it. So let's go back to the Bluemix actually. I've got such sample application, Node.js application created on the public Git. So I can easily deploy this application to the cloud. By the way, you can also use dashboard to create such deployments. You can see that our model is present here. Yep. Okay, so we got such sample application. The app is really sample. This is a Node.js app. It looks like that. We can easily deploy it using a deploy to Bluemix button. What it does, it basically creates a tool chain, which is like a build pipeline. It clones the code from the public Git to the Git served on the Bluemix cloud. It creates a build pipeline and it basically deploys it to the Bluemix. So I'm not gonna do it right now because it takes some time. I have already did it before the presentation. So we can go back to the Bluemix dashboard. Okay, you can see this is the Node.js application deployed just before the presentation. We can take a look at the details. You can see here several sections like build pack, number of instances, memory per instance, and so on, the cost of hosting such app on Bluemix cloud. Some kind of runtime information, connections, it's quite important. So this is like this, like I mentioned before, binding capabilities of application with the services offered by the Bluemix. So I have already bind that application with the Watson Machine Learning service instance I have created. And of course we got a route we can run. So the app has been started. The app connects to the service instance and lists all deployments of product line prediction model. So you can see two of them. The first one is the model I have saved after tuning, and the second one is the model we have just created and persisted. So we can choose any of them actually, any of those deployments. And then we got 4 customer records in form of the graphics here. So for example, we got Alice, 19 years old, single, female. So we can choose this record, hopefully, and try to generate predictions. Okay, so we can see that Gregory, profession trades, 57 years old, married, is interested in mostly in golf equipment with 67% of convenience. Of course, he's also interested, maybe interested in other product lines, but the probabilities are definitely smaller than for the golf equipment. So this is a basic end-to-end scenario, how to go from the model creation to up and running Node.js application on cloud. It took several minutes, maybe a little bit more. So the question is it all? So is it enough? So actually the answer is no, it's not enough. We got some kind of predictions, but the question is, are those predictions reliable? How to measure how good those predictions are? And the other question is, are they good enough to make some action based on them? So right now I'd like to show the second demo. Let me close it. Let me go back to the dashboard actually. So I got another model prepared. That model is the model that predicts one of 5 medications to treat heart diseases. So the goal of it actually is to select one of those 5 medication and suggest them for particular patient. We can see that the data is also quite simple. I hope you can see it actually. It contains personal information about patient like age, sex, and also results of some medical examination like, for example, KNA, cholesterol, and so on. We can see that the model was developed with the following accuracy, 87%. Maybe I can make it bigger, let me see. Okay, 87%. The threshold has been set to 80%. What the threshold means basically, so the data scientist, when he prepared this model, he evaluated that model, and during the evaluation the accuracy of the model was 87%, so such information was persisted in metadata of the model in Watson Machine Learning. He also decided that if the model quality goes below 80%, that model cannot be used anymore. Someone should be alerted, a notification should be sent, or maybe other actions should be triggered. Now we come to the feature which is called continuous learning system. So the continuous learning system provides capability of such model in production monitoring, of such model in production retraining and redeployment. So let's deploy the model first actually, because I think it's not deployed at all. Yep. So yeah, so exactly the same thing what I did using Python client, we can do it through UI. Okay, type online. Okay. We got one deployment of the model. Okay. So let's try to set up such a continuous learning system. Okay, so first we need to provide the information where our feedback data is located. So this is basically connection to the database. In that case, I'm using a DB2 on the cloud. We provide the minimal data size. So we basically say if this feedback data contains less than 30 records, it doesn't make much sense to run this system. We provide a Spark connection. This is a Spark model. We provide a Spark connection to the Spark service also on the Bluemix cloud. We provide the information about accuracy threshold, and that's basically all. We got also 2 checkboxes that we can use. So we can decide to automatically retrain a model if the model performance calculated based on the feedback data is lower than the specified threshold. And the second checkbox, we can decide to automatically redeploy the model when newly trained model version is better than currently deployed one. So for this first exercise, I'm not gonna use those features. I just want to use this continuous learning system as monitoring system. I just want to take my feedback records, use them to evaluate my deployed model to see how good or bad it is. So let me set it up. Okay. And let me run it. Okay, we can see that the learning system has been started. It's using Spark, so it's starting the Spark kernel first. Not sure. Yeah, I think you can see it. Okay. It takes a second, so in the meantime, we can take a look at the chart. So on the chart, we only see the initial information about the model accuracy, the one that was persisted by the data scientist. So the initial value is 87% of accuracy, and the threshold is set to 80%. Okay, we can go back. Okay, we can see that the model is being evaluated. We can see that evaluation has completed. We'll need to wait a few more seconds to refresh the table. Okay, we can see that new record has been added. So we can see that based on the feedback data, our model performance has degraded comparing to the initial value. It's 75% of accuracy and it's below the specified threshold. So not good actually. We can also take a look at the chart. We can see that our model performance in production is below specified threshold. So we can go back to the continuous learning system configuration to configure it to use full capabilities it provides. So we can decide that if the model performance is lower than the threshold, we know that it is, we want the model to be retrained using original training data and newly provided feedback data. And we also want to redeploy the model on the fly. So the model that is being served right now and it's integrated with our application provides reliable predictions. So let me set up the system again. Okay. We can also see that the information after evaluation about the model quality has been refreshed and it shows the accuracy. The current accuracy of deploy model is only 75%. Okay, let me run it again. So the iteration of learning system is starting again. The first phase is gonna be identical to the one we ran before. The currently deployed model gonna be evaluated using a feedback data. So we'll see one more entry identical to that one. Okay, the model is being evaluated. I'm right now triggering each of iteration manually by pressing evaluate button, but of course in real use cases scheduler will be used for that. Okay, so we can see right now that model is being retrained. We can see that original model is being updated, new version is being added. We can see that new retrained version is being evaluated. Maybe one more comment to the feedback data store. There's a REST API endpoint that allows to send new feedback records to the database on the fly. Okay, we need a few more seconds to refresh the table. Check it out. Okay. And what happened actually? So maybe the chart's gonna be better. Okay, we can see that initial model accuracy was at 87%. Then we use monitoring capabilities and feedback data to check if our model within time still provides accurate predictions, and it occurred that the accuracy of the model degraded and is below of specified threshold. We got the same information run again. Next, we schedule the retraining capabilities. So if the model performance is below specified threshold, retraining should be triggered. So retraining has been triggered, new version of the model has been created and has been redeployed. You can see that new version of the model shows accuracy at 84%, which is above specified threshold. Sorry. We can also take a look at the version history. So we can see that the original version, which after monitoring showed accuracy at 75% below specified threshold, has been replaced with newly trained version showing accuracy at 84%. And actually this is all I had to show. Yep, that's all. Thank you.
Are there any questions? I know that, yeah, we're all tired now, but...
My question is, in this very last section that you showed, how do you prevent overfitting?
Could you repeat?
In this retraining of the model,
Yes.
in this whole operation, how do you prevent overfitting?
So we are using a cross-validation for that, and we are keeping the so-called holdout data set to evaluate retrained models, so to make sure that we are not overfitting. And so first cross-validation, we are providing a K of free, so number of faults are free, so we are checking the quality of each fault. At the end, we are retraining on the full data set. However, we are keeping the holdout data set, which is used to evaluate the model to make sure that we didn't overfit. That's basically all, actually. Yeah.
Any other questions from the audience?
Yep.
Just a short question. What data sources do you support for the models? I mean, for the data, for the underlying data of the models.
So, what do you mean by the models? You mean the model deployments, like a batch and streaming?
Yeah, in terms of like when you build the model, like in the first part, where do you need to put the data to train the model in Bluemix? What options do you have?
Just. One second. You are referring to this notebook when I was creating a model, or this one? Okay. So we support object storage, Bluemix object storage, which is kind of equivalent of Amazon S3. This is one thing. We support databases. We also support. Actually, we can check it out. Yep. Flat files like CSV files and connection to the, let me check, internal and external databases, I think. Good question, by the way. Yeah, it will take some time. In context of the streaming, we support Message Hub on Bluemix, which is equivalent of Kafka.